This video is an exclusive excerpt from our latest FSW webinar. If you're interested, the complete replay is available for free by following the link in the description. Have a nice viewing.
Hello everybody. Thank you for being here for this second session of our first webinar of the year. So for today, I'm with Laurent, our CEO and Friction Stir Welding expert. The topic of today is Stiffened Panel Welded by Friction Stir Welding. We will dive into two main subjects. The stiffened panel made by extrusion and stiffened panel made by high strength alloy. So now let's the expert present. So Laurent, time to shine.
Thank you, Kim. Welcome. Good morning, good afternoon. Happy New Year. We are glad to meet you for this webinar. So this is the content of my presentation, a short introduction about Friction Stir Welding for beginner. After stiff panel from extrusion, so it's based on made in 6000 aluminum alloy, and as my colleague Kim mentioned, stiff panel from high strength aluminum from 2000 or 7000 aluminum alloys. So just one slide to introduce Stirweld. Stirweld was founded in 2017. We are 32 people in France, but also in USA, in Detroit, where we have facility and prototyping facility with a spare part for our North American customer. And we are opening a facility in Germany. So soon we'll have a third facilities in Germany to support our German customers. So our main product is this blue box. So it's a unique product. So it's a Friction Stir Welding head for CNC. So you can plug this head on any CNC machine, and you can use your CNC machine for Friction Stir Welding. And the main advantage of this head is the cost compared with full dedicated Friction Stir Welding machine. And also we offer different services. Friction Stir Welding tool. So as we can see, using my mouse is the process consumable. Of course, we offer a turnkey solution, including part design and welding qualifications and welding jig, and of course training. So can be on-site training or online training. And so today it's a webinar, so you can consider like a free training, but generally our training is 3 days. So today you just learn a little bit about Friction Stir Welding, so don't hesitate to contact us to get more longer training. Okay, for beginners, and here we have some beginners in attendance. Friction Stir Welding process can be divided in 5 steps. The first step is to clamp the part. Why? Because we plunge a tool into the material and we push this tool. So the clamping is very important to avoid any movement of the part during the Friction Stir Welding process. The step 2 is we use a special Friction Stir Welding tool. So you will see on the next video the special shapes of the tool, and you use a tool depending on your weld penetration and also what kind of material you are welding. So you can download our FSW tool catalog by clicking on in the right box. So you can download our catalog and you can pick up the tool that you need according to your weld penetration and material. So after the tool is placed in rotation, plunge into the part up to the shoulder touch the top surface of the part, and we start the traveling along the piece. And this combination of rotation plus linear movement create this steering effect and mix the material together. Okay, so now for stiff panel, most of the time, today we are using arc welding, can be TIG, generally it's a MIG welding, to weld extrusion together to get a stiff panel. So in this chart, we compare the different properties and we compare arc welding, mainly MIG welding versus friction stir welding. So if we look the mechanical strain, friction stir welding is better. Why? Because we can weld any kind of aluminum alloy, including the high strain aluminum alloy such as 7075. Second point is the joint efficiency. As you know, can be 6000, 2000, 7000. It's heat treatable aluminum alloys. So when we weld, we increase the temperature, so we reduce the mechanical strain because we reduce the temper of the materials. So as friction stir welding is we weld at lower temperature than arc welding, in fact we reduce less the mechanical strain. So if we compare the joint efficiency, the joint efficiency of after friction stir welding is generally 2 times higher than after arc welding. And the same thing, so joint efficiency is we measure the tensile property. We observe exactly the same property for fatigue resistance. So generally the fatigue resistance of friction stir weld is 2 times higher than arc welding. Now, what about welding cost? For arc welding, we use sheeting gas and we use filler metal. And while the only friction stir welding consumable is the tool. And a tool, the lifetime is from 1 to 2 kilometers. So generally, we said that the welding cost of friction stir welding is 10 times cheaper than arc welding. Now, the main problem of friction stir welding is the gap bridging. With arc welding, we feed the material, we add wire. So this wire feed the gap between the parts. And so we don't have material feeding in friction stir welding. So the maximum gap is 2 mm for MIG welding, while is maximum 1 meter in friction stir welding. Now, if we look to welding speed, maximum arc welding it's and MIG welding it's 1 meter per minute, while we can reach 3 meters per minute by friction stir welding. Part distortion is like joint efficiency. As you know, the main problem of welder generally it's part distortion. But as the process temperature is 2 times lower with friction stir welding, the part distortion generally is 3 times lower. Not 2, but 3 times lower. Now, to finish, let's go about leak proof. As friction stir welding is solid state process, we don't have porosity or hot cracking defect. So in terms of leak proof property is generally perfectly leak proof. So that's why friction stir welding is a lot of we have many applications for heat exchanger with water channel because it's perfectly leak proof. And the last advantage is galvanic corrosion, as we don't have galvanic corrosion because we don't change the the chemical composition of the aluminium, because we don't add an external wire. So we keep the base metal chemical composition, so we don't have galvanic corrosion. So that are some examples of our customer using our Friction Stir Welding head for CNC worldwide to produce stiff panel. So in North America and in South Korea and also in Europe. So all these customers use every day our head to produce a stiff panel by Friction Stir Welding. Okay, so let's go about stiff panels from extrusion. And of course, as you know, we can only extrude 6000 aluminum alone. So this kind of application, so we have different kind of application, and today the main family of application for stiff panel from extrusion welded by Friction Stir Welding is Navy sector. So here is some example of real ships using aluminum panels produced by Friction Stir Welding. So it can be ship or offshore platform to reduce the weight into the upper levels of the platform. And same thing for cruise ship and for civil transport. So in this case, the process is very simple. We start from profile. So here we have an example of a T-shape profile. And the idea is to weld this T-shape profile using butt weld to get this stiff panel. So here we have a 10 meter long panel, but of course it can be shorter, it can be longer. And here I like this example because we can see one tip is how to remove the exit hole here at the end of the weld. So so the application is Marine Aluminium Norway, and they add this run out tap. So as you can see, it's an external part placed into the jig, and so we complete the weld into this run out tap, and we cut this run out after welding. And so this is very smart because we save material from extrusion just by adding an external piece of aluminium, and we can easily cut this run out after. Okay, the second family of application for stiff panel from extrusion is electrical car. It can be electrical vehicles, because we have a similar application not only in car but also in bus, truck, yellow engine, ships. So in fact, where we need batteries, we need a battery tray or battery casing. So I will show the principle of this battery casing. Is so this battery casing is composed of two different parts. The first part is the floor here, and so we start from extrusion, and again we weld by Friction Stir Welding and butt welding this extrusion to compose the floor. And after we will weld a frame here onto this floor. So in fact, generally for this kind of application, we have two kind of weld: butt welding to get the floor, and lap welding to weld the frame onto the floor. And so of course we reverse the battery casing, and we get this this casing. So here I will show you an example. So in this case,
There's still 30 minutes to watch. Access the full video for free by clicking the link in the description below. And don't forget to subscribe to our channel to learn more about friction stir welding.